Hey class, today I'm going to show you how to simplify rational expression. Basically, they're fractional expressions. First, we're going to start out with monomials in the top and in the bottom. Remember, a monomial is just one term, no pluses or minuses. So basically, you reduce this just like a regular fraction. It's negative, so it'll stay negative. What goes into both 90 and 36? 9 goes into 90 and 9 goes into 36, but I don't think that's the biggest number. We can go ahead and do 9 into 90. That is 10. 9 into 36 is 4. And you can see I didn't use the biggest number. It will reduce again. 2 goes into negative 10, be negative 5. 2 goes into 4 2 times. So 18 was probably the highest that we could reduce that by. Now with the variables, you have 3 x's on top and 2 on the bottom. All 2 of those will cancel with 2 on the top, and you're left with 1 on the top. So your final answer should be negative 5x over 2. Next one, same deal. You have monomial expressions. Reduce 24 and 36. What's the biggest number that will divide into 24 and 36? 6 goes into 24 4 times. 6 into 36 will go 6 times. You still have a common factor in there. I think 12 would be the biggest. 12 goes into 24 2 times. 12 goes into 36 3 times. And then with your variables, you have 5 a's on the bottom and 6 on top. All 5 will cancel with 5 from the top, and you are left with 1 on top. So your answer is 2a over 3. All right, now, sometimes you have polynomials on the top and the bottom, which have the pluses and your minuses. You don't have just one term, you have more than one term. So to solve, we look for common factors. And when we're looking for common factors to reduce, we basically factor. If I can factor the top, I'll factor it. If I can factor the bottom, I will factor it. And then I will cancel out my common factors. So on top, I have a GCF of 4n. If I take 4n out of the top, I'm left with n minus 5. And then on bottom, it's just 4n. Now I can cancel the 4n with the 4n, and I'm just left with n minus 5 would be my answer. It is now simplified. The next one, okay. Now, a common mistake is to want to take this x and cancel it with that one. You cannot do that because this x is joined with the 3 by the plus sign. So if it's joined with pluses, you can't take it away from the rest of the problem. If it's joined with a plus or a minus, to cancel it with something else. Times we can, but pluses and minuses we cannot. So we have to factor it first. Now the top will not factor, but the bottom will factor into a product of 2 binomials. Reverse FOIL, x squared is x times x. What multiplies to give me 6 and adds to give me 5? That's 3 and 2, and everything's positive. Now we can cancel out factors. X plus 3 is a factor, x plus 3. And if everything cancels on top, you have to put that 1 there, and then we're left with x plus 2 on the bottom. Okay, next one. We factor the top and the bottom, and please do not try to cancel the v squares or the v's. That would be incorrect. All of this is together. We first must factor it and cancel out common factors. So on top, It factors into v squared is v times v. And then what multiplies to give us 18 and adds to give us 9. That's 6 and 3, and everything's minus. Signs should be the same. Then let's factor the bottom. V squared is v times v. What multiplies to give me 12 and adds to give me 8. That will be 6 and 2, and everything's the same. Signs will be the same, both minuses. Now we have them factored. Now we cancel out common factors. We got a v minus 6 and a v minus 6, and then we're left with v minus 3 over v minus 2. And please do not try to cancel those v's. That will be incorrect. V is joined with the 2. V minus 2, it stays together. Next one, we factor. Top and bottom. Top, k squared is k times k. What multiplies to give us 63 and adds to give us 16? That's 9 and 7. And signs are both negatives. On the bottom, k squared is k times k. What multiplies to give me 81 and adds to give me 18? That's 9 and 9, both negative. And what factors do we have in common? K minus 9, k minus 9. We can cancel those. So we're left with k minus 7 over k minus 9 as our final answer. Next one. Now don't forget the first step in factoring is a GCF. And we have a GCF in the top. We can take out a 2. And that leaves us with n squared minus 2n minus 3. And on the bottom, we can take out a 3. That leaves us with n minus 9. Now on top, that will factor again. What's in parentheses? Remember factoring completely. If it'll factor again, we factor it again. It's that trinomial. We reverse FOIL. N squared is n times n. What multiplies to give us 3 and subtracts to give us 2? That's 3 and 1. 3 is negative, and the 1 is positive. And on bottom, it stays 3 times, made a mistake. When I factor out a 3 over here, that becomes a 3, not a 9. Okay, so then that's 3 times n minus 3. And then our common factors, n minus 3, n minus 3. And we're left on top with 2 times n plus 1. Now you don't have to distribute that unless you want to, but you don't have to. You can leave it as a product, 2 times n plus 1 over 3. Next one, same deal. First look for a GCF, and we have a GCF of a 2. We can take a 2 out of the top, and that leaves us with p squared minus 4p plus 3. On the bottom, we can take out a 2. That leaves us with p squared minus 4p minus, that's not minus 4p, another mistake. Take out a 2, that's 2p. And then take out a 2 from the 6 is a 3. Okay. And then we can factor again. P squared is p times p. What multiplies to give us 3 and adds to give us 4? That's 3 and 1. Both signs are the same, both negatives. On the bottom, what p squared is p times p. What multiplies to give us 3 and subtracts to give us 2? That's 3 and 1. 3 is negative and 1 is positive. And then cancel where we can. The 2's, we can cancel the 2's and the p minus 3's. And we're left with p minus 1 over p plus 1.